Section 8.4, Similar Triangles. By the end of this lesson, you should be able to identify similar triangles and to use similar triangles to solve for angle measures and side lengths. Last lesson, we talked about similar polygons, and we should really review about what it means for triangles to be similar. And just like any other polygon, we needed to see that all corresponding angles are congruent, and we needed to see that all corresponding sides are proportional. And if this happened, then we can say that the polygon was going to be similar. Now, that's 6 pieces of information that we need to find, because you'd have to find 3 pairs of congruent triangles and 3 pairs of proportional sides. That's a lot. Fortunately, we do have some shortcuts. The first one is, and the one that we're going to focus on today, is the angle-angle similarity postulate. So this just says that if you have 2 angles of a triangle that are congruent to 2 angles of another triangle, then the triangles are similar. So it's only 2 pieces of information that you'd have to look for to say that triangles were similar. Let's see this in action. This says, are the 2 triangles similar? And if so, explain how they are similar. Well, we have given to us that angles B and L are congruent, and we can mention that. This is because they're both right angles. And we can also say that angle AHB has to be congruent to KHL. And this is because they are vertical angles, and we know that vertical angles are congruent. So, since we have 2 pairs of corresponding angles congruent, we can say that the triangles are similar. So we'll say triangle AHB is similar to triangle KHL by the angle similarity postulate. Okay, let's see how this acts in the real world. So here we have a whole bunch of wheelchair ramps, and as you can see, this one is not good. If somebody had a wheelchair, it'd probably be difficult to maneuver up this one. We have this one. Once again, it looks like it's too steep. We also have this one, short and steep as well. And this one, that kind of just seems to drop off. Well, in order to fix this, the Americans with Disabilities Act, and to make sure that bad wheelchair ramps aren't actually going to be built, all ramps have to have a height to length ratio of 1 to 12. If the height from the ground to the floor is 2.5 feet, how long must the ramp be? And in order to solve this, we can go ahead and use the idea that all of these triangles, so all these ramps formed, have to be similar to one another. And it has to have a 1 to 12 ratio. And it says that this is going to be the height to the length. So with the triangle that we have here, we have a height of 2.5 feet, and our length is unknown. So I'll put L as a variable in place of it. And once we have our proportion set up, we can solve. And we're going to get L is equal to 12 times 2.5. And if we simplify, we'll find out that the length of our ramp will have to be 30 feet. Let's see some more examples. This one says that we're standing 15 meters from building A and 50 meters from building B. And we know that building A is 90 meters tall, and we want to find the height of building B. So I'm going to put H in place of this because this is what we're trying to find. Now, if we knew that these triangles are similar, then we can go ahead to set up a proportion. So let's go ahead and do that. Well, we see that they're giving us that these angle measures are congruent, and the angle formed by the ground to the building for both of these buildings is going to be a right angle. So we can say that the triangles are similar by the angle-angle similarity postulate. so we can continue. And our proportion that we're going to set up, let's go ahead and say that we're going to call this, our distance to the building, and then this is the distance height. So we have that 15 corresponds with building A, and 50 corresponds with building B. And that'll be equal to 90, the height that corresponds with building A, over H, which is the height that we're trying to find for building B. And from here, we can solve by cross multiplying. So 15H will be equal to 4,500. And then when we divide both sides by 15, we will find that H is equal to 300. So the height of building B is 300 meters. And that is pretty much it. So it's time for our joke. And our joke today is, why do dragons sleep during the day? Well, they sleep during the day so they can fight nights.